This project demonstrates how 3D transformation are used to create an interactive 3D version of the Twitter X logo. It's so one object can rotate, scale, translate, and replicate. Good morning and good afternoon. Today I will be presenting my linear algebra project on 3D transformation. I create an interactive program that transforms the Twitter X logo using Python. We build a 3D model of the Twitter X logo, two bars crossing to form an X. The cool part, you can control it with slide to do three something. Rotate it in any direction, scale it bigger or smaller, translate it to move it around. Everything updates in real time as you move the slide. We use Python for coding and NumPy for all the math calculation. The X logo is made of two 3D rectangular bars. Each bar has 8 corner points, 4 in front and 4 in back. One bar goes from bottom left to top right. The other goes from top left to bottom right. When we put them together, they make the X shape. We connected this point to create 6 spaces for each bar, making them look solid and 3D. Now, the important part, the linear algebra, we use space for X for matrix. For all transformation, translation matrix. This moves the logo. The movement amounts go in the last column. We can move it left, right, up, down, and forward, background. Rotation matrix. This spins the logo. We made 3 rotation matrices, one for each axis. They use sine and cosine to rotate the object while keeping its shape. You can spin it 360 degrees any direction. Scaling matrix. This changes the size. Number bigger than 1 make it larger. Numbers smaller than 1 make it smaller. Each direction can be called separately. We use 4x for matrix because of something called homogeneous coordinates. This lets us treat all transformation the same way as matrix multiplication. Here's K linear algebra concept. We can combine all transformation into one matrix by multiplying them together. Our formula is that means translation x all the rotation x scaling. Important, the order matters. If we apply in a different order, we get different result. This shows that matrix multiplication is not communicate a big concept from our class. We apply transformation from right to left, scale first, then rotate, then translate. Linear algebra final project. Here's our Twitter X logo in the middle. On the left, you see all the current transformation values. At the bottom are the sliders. Watch, I'm routing it around the x-axis. See how it's spin, the value on the left updates automatically. Now let's make it bigger on the x-axis. Translation moves it around without changing its shape. I can combine all three at once, rotates, scale, and move it. All the transformation work together. And the reset button brings everything back to the starting position. Homogeneous coordinates. Why we use 4x4 matrix for 3D stuff. Matrix multiplication order matters. Change the order, get different result. Real world application. Video games and 3D animation use this exact same matrix. The best part was seeing the math actually work. Moving a slide and watching the logo transform made all those matrix equations from class finally make sense. This is how all computers graphics work, games, movies, 3D modeling software, they all use transformation matrix just like we made.